one of the most important empirical methods in software engineering, that is case study research. Is one of the most common approach because software engineering is engineering, so is dealing with building objects, transforming processes, and it is by nature oriented towards the study of specific cases in industry. So let's see first what we mean by case study, because it is a term that is often misused in practice. So let's start with some definition from the book from Runeson and others that is linked here. If you see, there is a link to also case study research in software engineering, the slides from Easterbrook and Aranda, and a link to the paper of Schull et al. So if you want to get more accurate information, please refer to these books and to these slides, because my slides are built based on those paper and slides. So what is a case study according to the book? Case study in software engineering is an empirical inquiry that draws on multiple sources of evidence to investigate one instance or a small number of instances of a contemporary software engineering phenomenon within its real-life context, especially when the boundary between the phenomenon and context cannot be clearly specified. This is a quite long and somewhat complex definition, but your attention should focus on a few elements that are fundamental here. Multiple sources of evidence. So you want to consider different types of data from different points of view. So this already suggests you that this is not just qualitative or quantitative, but it is oriented to mix up all the things that you have learned in the previous lectures. It investigates one instance, so one or few instances, so a few cases of a contemporary software engineering phenomenon. So a phenomenon that is not historical, it's something that is relevant now. So although you are focusing on just one specific instance, somewhat this instance should be representative of something that happens in other companies, in other reality. And it is investigated within its real life context. So in software engineering, most likely will be an industry that develops software or systems in general, especially when the boundary between phenomenon and context cannot be clearly specified. As you remember, when we discussed experiment, I will compare experiments with the case study in the next slide, but when we discussed experiment, we focused on separation between variables and context. In here, the focus is actually on the relevance of context for the phenomenon. So there are some phenomena that cannot be observed in a lab experiment. For example, phenomena related to large software projects or long development time that need to be studied in the real life context. And this is what is of interest of case studies. And many of the phenomena related to software engineering are complex phenomena. As you remember from the first lecture, they involve social aspects and technical aspects. So they mix these different types of dimension in a way that should be studied in an homogeneous way. And case study is the strategy to address in a systematic way this type of environment. Let's see other definition that I gave to provide you other perspective on what a case study is. Let's see the second point. A case study is a research industry collaboration carried out and reported with an empirical software engineering mindset. Okay, so what does it mean? It means that a case study is any collaboration that university does with industry. This is not an absolute definition, okay? But in most of the cases, is carried out in a research industry collaboration, which is carried out and reported with an empirical software engineering mindset. What does it mean? That you have to bring with yourself all the background on experiments, surveys, and qualitative studies, all the things that you've learned up to now, and you have to use those paradigms to interpret the reality, the industrial reality, and to carry out research in a systematic way. So a case study is any research that uses real industrial data sources. So either you do something that is more focused on qualitative aspects, you probably interview developers, but it normally involves multiple sources of evidence, so developers, but also documents and software. Real industrial data sources, not examples. So something that really comes from the reality and really takes into account all the characteristics of real life context. Analyze the data considering the specific context, so the characteristics of the company and the people. So this analysis of the data is not completely general. Is carried out considering the context of the developers, the context of the documents in the process, and the context of the software within the whole process, the software that is engineered and that is the product of the process itself. And a case study is designed and reported with an effort towards objectivity and generalizability of the findings. So this is what an empirical software engineering mindset means. So although you're focusing on a context, on a specific context, you want to generalize. You want to observe the things in a way that makes it possible to compare your finding with other findings, and as you remember, extend the scope of validity of a certain research, and effort towards objectivity. Of course, as you already understand, the researcher is highly involved in a case study, so objectivity is not always possible. But by means of triangulation, approaches that allows you to consider the different sources of evidence, your goal is to reach objectivity. And you reach generalizability by an accurate definition of your context that will allow other researchers to understand to which extent your findings can be ported to other realities. Okay, so this is what in general case studies. I think I gave you a quite comprehensive overview. Let's go more deep on the definitions, because it's quite important. Here you see the radical difference basically between an experimental case study in terms of attitude of the researcher. So in an experiment, you need to know the reality and you need to port it in the lab. Port it by simplifying it, so selecting variables, measures, and minimizing the context. So you want to get to focus on variable and isolate them. So if you remember, to control a set of variable in a way that minimize the influence of context, because you want to see the effect of a certain variable over another dependent variable. On the other hand, a case study, you can see it at the opposite. It requires the knowledge of empirical tools that you would use in the lab, so the same empirical tools, but you don't get away from the reality, but you bring those empirical tools in the reality. So it's not anymore bringing the reality in the lab, but bringing the lab in the reality, and considering therefore context and maximizing realism. So this is the core difference that you should remember. And I think it's key again to emphasize the need to know empirical tools and work with an empirical software engineering mindset, with a goal of objectivity and a goal of generalizability of the findings. So let's take again our diagram that we've seen in all our studies, in all our overviews of types of research strategies. And here you see that case studies are mostly applicable, of course, when we focus on context. So increasingly more specific contexts and systems. Typically, a case study is used in field studies and field experiments, but is also the topic of experimental simulations and computer simulations. Why? Because these are normally focused on specific companies. So that's why they are used. Case study approaches are used also in these cases. But normally, what we find more frequently in software engineering is field experiments and field studies, as we already discussed. Sorry, I switch off the phone because, as we already discussed in the previous lecture. So field experiments and field studies. We've seen already qualitative studies that are mostly associated to field studies. So we can say that what we will discuss and exemplify during this lecture is mostly related to field experiment. Okay, but case study is a general name that refers to any study that you do in a company or with the real data of the company. When to use case study? This is taken from Easterbrook, and these are the theoretical principles that you should follow when selecting case study as a research strategy. First of all, when you can control the variables, when there are many more variables than data points. So the context is complex, you have several variables, but you have few people or few documents. You cannot separate phenomena from context. So as I said before, you have to want to observe phenomena that don't occur in a lab setting. So aspects that are related to the scale of the company or to the scale of the project itself, or the naturality of the interaction between people. Because of course, people in a lab don't interact in the same way as they interact in their own setting. And for effects that take a long time to appear, so things that cannot be constrained in the lab experiment that last a couple of hours. So, and you understand that in most of the cases in software engineering, these are the typically interesting thing, because between the moment in which you write your first requirement and the moment in which the software is running, there is a very long time. But these elements, the elements that brings you from the requirement to the software, are clearly interconnected. And of course, phenomena takes a lot of time, and they are influenced by many factors. So that's why case studies is the most common. Of course, whenever the context is important, so when the context has a main role in affecting the phenomena, and whenever you need to know whether your theory that you've developed in the lab, basically, or through an experiment also, may apply to a specific real-world setting. This is in theory, and this is all true, of course. But in practice, when do you use case studies? You normally don't have so many choice. You cannot decide so much, because in some cases, there is a company that wants to try a software engineering support tool that you developed. So you may have developed a tool for identifying requirements issues, to support traceability of requirements, to support bug detection, anything that can support software engineers in the company. They want to try it out on their data, and this is the most common way in which any case study starts. So the company interacts with you and want to try something to improve their software engineering process. In other cases, it may happen that they want to try an existing tool in their process, but is not developed by you. For example, is a new tool for model-based development. So they want to start introducing this tool, but they're not sure the steps to take, so they prefer to have a researcher, an external subject that does this with the documents, with the requirements of the company or the software of the company. So as a parallel activity, like a parallel research activity to pilot or to perform a feasibility analysis on how introducing this tool would be for the company. Or when a company wants you to develop actually some tool or process to support their software engineering activities. So probably there is also something in between. You have developed a tool for software tracing or requirements analysis, and they want to adapt and develop more for the specific context of the company. Or other cases, very typical, if you are funded with a collaboration project, for example, from the European Union or your region with industry, so that a project that has been set up for a technology transfer project, for example, and you want to publish the results in a software engineering venue and not just do the work for the company, because this is concretely what happens. Like you need to develop something for a company, but since it is what you develop, it is very close to reality, is not perceived, is not considered enough research for many venues. In software engineering, it is possible to publish this research if you structure the research since the start with an empirical mindset. So if you set up a case study since the start. So if you this will be useful to you if you may be involved, if you are involved in a collaboration project with industry and you are at the university or you are in the industry itself. It is important that you understand that whenever you do something and you interact with a company and you develop something for them, you need to publish that. And for software engineering, one of the few ways of publishing something that is already close to technology transfer is to use a case study. And this last point is more rare, but it's the case that we consider with qualitative case studies. And it happens when you have already good contacts with the companies. So where you have established a contact because previously you developed some tools, or you already had a project together that was funded by some entity. And you want to study something that interests you, study a general problem and general software engineering problem in practice, so communication, etc. But this type of studies, since they are related to building knowledge, they are mostly descriptive. Of course, there is rarely there is a founded project that allows you to perform this study. So most of the cases, these studies are curiosity driven somehow, and are based on good established contract with some industries. Okay. Typical examples in which of cases in which you do case studies is the case in which you are a PhD student and you are in the company for 4 days per week, and you are experiment with a commercial tool for code generation using requirements from a previous project of the company. So the company wants to introduce automated code generation from models, and but they want to carry out with their current development activity. Okay, and they want to understand to which extent it is possible for them to follow that path. Okay, and they involve you as a micro research team in that company, and you start experimenting with this tool using as a source the data of the company, so a previous project. I put the 4 days thing because it's extremely relevant, because the context is not just the context of the document or the process. The context is also the physical context. Understanding the culture of the company, understanding the processes is something that that you capture when you are there, and it's harder to capture if you are not in the company. The second case is a bit different, that you stay at the university, but you use the requirements and code from the company, and you develop a tool for automated trace link detection. So in this case, the only thing that you get from the company is their requirements, okay? And so you are not influenced, you are not in the context of the company in a complete way. So this is a bit more difficult to carry out, but at least it separates a little bit better the context, so it can be studied in a more systematic way, but it is less likely, let's say, to be successful, because how many meetings can you do with the company? This is of course limited, while if you are always there, you can meet every time. This might seem obvious to you, but this is what makes the difference, actually. Contacts, communication, staying there, being there, and having to deal with the people, gaining trust with the people. We said this already when we spoke about qualitative study. This is what makes the difference between a successful study, something that leads to a result that is improving the company and improving the research, the knowledge, from a study that just explores in a more limited way the context of a company. The last one is the example of qualitative studies that we considered in previous lectures, and you are not developing anything in this case, and you do observation or interviews. So this is you already know a lot about this type of studies. What is not a case study? Case study is not an example, so it's not just a simple example of a case, not a toy problem. You need to use real data. It's not an experience report, so it's not. This is the thing that often creates a lot of confusion. An experience report is a retrospective report on an experience with lesson learned. So you've done an experience with the industry, and you report afterwards some lesson learned, and you didn't really plan the case study, and you report in a historical way. So this is not a case study, okay? Because it's less structured, it's not based is not carried out with an empirical research mindset, and not a quasi experiment with small n. So you don't perform a quasi experiment by isolating some variable or doing the experiment with very small sample size. So this does not work. Generalization in case study is based on similarities between contexts, okay? And we will consider this later on. So this to clarify what is a case study and what is not, okay? It's not an exemplar, not an experience report, and not a quasi experiment with a very small number of units. Fundamental characteristics again, not really again, but the thing that you should consider to recognize a case study and to build a case study. Case study has research questions that set out from the beginning of the study, like any method that we studied, okay? We always start with a goal and set of research questions. Data is collected in a planned and consistent manner, so you are systematic in your way of addressing your case study. Inferences are made from the data to answer the research questions, so there is a clear link between the research questions and your findings, like in experiments, like in qualitative research, and this is actually a mix of all this. It produces an explanation, description, prediction, or improvement of a phenomenon. We see this now. You already remember the different types of empirical inquiries in which we were the explanation, description, prediction, and improvement. And it lists and addresses all the threats to validity in a systematic way. Also, in this case, we have discussed the different type of threats, and we will see those that apply to case studies at the end of the lecture. So, types of case study. You can distinguish the case study between the stage and the goal. You will find something different in the literature, but I think that this is the most understandable way of classifying case study. The stage can be either exploratory or confirmatory. In exploratory, you are searching for new hypotheses. You have never studied a certain phenomenon, or you have little knowledge. You want to build up some theory. This theory can have different flavors, and the flavors are given by the goal. But the stage is exploratory. It's the first time that you go there. It's the first time that you study that. Confirmatory, in the case that a theory was already developed by you or by someone else, and you want to see to which extent it applies to your specific context. The goal can be descriptive, so understand what is going on. You build up a model of interaction, for example, between developers. Predictive, how, so you want to understand how to predict a certain variable, predict a certain outcome based on some independent aspects. Okay, so understand the relationship, for example, and guiding the choice of the background of the people participating to a project, for example, to predict success. This is a possible case. Explanatory, so again, you explain why certain things happen. This is, of course, as you remember, explanation in controlled experiments required that you control as many variables as possible, and you have a completely randomized experiment, so that you understand that that specific outcome is given by that specific modification of the independent variable. Of course, in case study research, this is more difficult. So explanation will mostly come from a combination of data, but mostly from qualitative analysis, of course. And improving case studies, it's the most typical one that, of course, answers the question how to, the case in which you, like in the example that I provided, you go in a company and you want to improve the process, for example, with the introduction of a new tool. These are the typical cases. Of course, there can be a mix. So normally you have, for example, an exploratory case study that is, for example, improving. What is the typical case? The case in which it is the first time that you try out that tool in a real context. So you are doing an exploratory case study. Then you have refined your tool, and you want to perform a confirmatory study in another company or in another group of the company. The approach is still improving, okay, but the spirit, the stage is confirmatory. What is the process? The process is a mix between the experiment and case study, if you remember the structure. In experiment, and the qualitative studies, if you remember the structure of those studies, we had in experiments we started from theory, and we get to discussing the theory, okay, with this deductive approach. In qualitative studies, you normally don't start from existing theories, but you build up the theory in a grounded way. So you in an inductive way. In this case, you have theory, and that is the case that is most representative of reality. Actually, you have theory before and after. Okay, you have some theory that exists, and some theory that is enriched by your finding. So you start from some background, you write down the research questions and constructs, you identify the context. This is a key difference between the other, between the case study and the experiments. You identify context, so involve the subjects and involve objects. We will see example. You do your research design, in which you define the units, the data collection procedures, the data analysis procedures, and the validity procedures. And then you carry out the whole process. The fundamental thing here is that, like in qualitative research, and case study has a strong qualitative aspect, there are iterations, because reality can modify your research questions, can lead you to understand that you didn't collect the data that were actually relevant for your research question, or simply because you want to iterate in order to understand better what is going on. For example, you develop the tool, but you want to refine it in a certain way. So there are iterations. And this is due to the fact that you normally mix different sources of evidence, so qualitative and quantitative data often. And remember that iterations can be performed with different goals and different levels. This, we normally speak in this case, is about iterative case studies. I will show you an example. Different goals at different levels means in one phase you are exploratory, in one phase you are confirmatory, and at the same time you can have a goal that is improving or is explanatory. For example, if you want to understand why you did not improve. Okay, so these are the way in which you should frame each step of your study. Of course, iterations are not always needed. If you are lucky and you can go through a smooth process from data collection to discussion and theory extension, you're lucky. But in most of the cases, you have to iterate. So let's see our running example. We will follow this example for the whole lecture. And actually, it's an example that is combining qualitative and quantitative data. It's a very simple example, but you will see that it will lead to very complex design and very complex outcome. So the example is concerned with a tool to detect requirements defect that is tried out by a company on their own requirements. So this company has a set of requirements that have been previously analyzed for defects. So you know the requirements that are defective and those that are not defective, like in the picture that you see here on the left. There was a manual defect analysis performed before. They want to see if your tool is at least as good as the people in find out those defects, as good as the requirements analyst. Okay. Normally, the expected results, so the results that are the requirements that have been analyzed by a requirements analyst is called the ground truth. This is in general the name for any set of expected results for any task. You may have heard this from lectures in artificial intelligence and machine learning. It's the same concept. Okay. So you get your requirements. In this case, of course, you don't give your tool any suggestions, so you don't give the marks, the tags as defective, not defective, and you have as output the requirements with the automatic defect analysis. So a classification between defective and not defective requirements. Some match with the one of the ground truth, some other did not match. You want to perform an analysis in terms of usability and accuracy, and it should be quantitative and qualitative. From the usability point of view, you want to have a quantitative analysis by means of a standard questionnaire given to people, given to different requirements analysts of the company, for example. For the qualitative point of view, you want to interview these people that used the tool and filled out the questionnaire, the usability questionnaire, to ask them for improvement. You want, for example, to organize a focus group. Okay. And for the automatic analysis, you want to evaluate the accuracy in a systematic way by comparing the output of your tool with the output of the manual requirements analysis, with the ground truth, and you want to study in a qualitative way the sources of inaccuracy. So you want to understand what are the typical classes of inaccuracy of your tool, the sources of so-called false positive and false negative. So this is a summary of what I already told you. So you have this tool, you want some measures that are related to, some measures that are quantitative, so the accuracy, for example, or the degree of usability, and some measures that are qualitative, so the typical patterns of inaccuracy and qualitative feedback on improvement. You already see that this usability and accuracy is seen from different perspectives, the quantitative one and qualitative one. Will be our running example. So let's follow our process. As you remember, we start from the theory, research questions, and context. What is the theory? The theory is the background for our research, is the theory from which we start, and by identifying the gap in the theory, you can explain the motivation for our work. You can give a motivation for why, for example, you didn't use an already existing tool in the company, or why did you need to apply, why wasn't this problem solved by someone else? Okay, so you list the existing theories that are about requirements defect. For example, you can refer the standards, this handbook of requirements ambiguity, studies on usability, and other possible tools for defect identification in requirements that you may search through a systematic literature review. For example, we will see this topic on Thursday. And you identify the gaps in the current theory, that is the motivation for your study. So, for example, gaps in current theory can be that previous tools were never tried in a context of a safety critical company, while your company is different, is safety critical. So you want to study how this theory about requirements defect apply to a safety critical company. Or other tools may not be made publicly available, so you are not able to try those tools in reality. Or at the same time, there was no usability analysis of the existing tools in practice, so your contribution is towards usability, or all these gaps altogether. So these are all the motivation that allows you, that already set somehow the gap that you want to cover in the theory. Okay, and the outcome, a vague definition of the extension of the field of validity of the scope of validity of the existing theory on requirements defect. Research questions and construct. You remember this, I recall it every time. There was a first lecture on how to formulate research question. Here, for case studies, it's quite typical to adopt this structured approach, which is called the Go question metric, that was developed by Basili. You can see the paper there, linked there. And the Go question metric is based, as the name say, on 3 elements, fundamental elements. You start from the Go, which is the overall objective. In your case, would be improve the detection of requirements defects. Based on this Go, you define the research questions that are relevant for you, and then you consider each construct that is discussed in the question, and plan your evaluation of that construct according to qualitative approaches or quantitative approaches. So this is a systematic way. You start from goals, you define question, and you define metrics that are mostly, of course, quantitative, or evaluation strategies that are qualitative, but all associated to the construct that you have identified. For example, in this case, the questions can be: how much accurate is the tool in detecting defects? Which are the typical sources of inaccuracies, so the patterns of inaccuracies? How much usable is the tool considered by the analysts? Which are the improvements required? So this is what we discussed up to now. And you say, okay, accuracy, I can measure it quantitatively with precision and recall. And you probably know this from information retrieval and machine learning theories. We will touch them afterwards, but consider, if you don't know them, you just Google them, but it's a typical way of measuring any information retrieval or classification task, okay, measuring the goodness of the results of the classification task. Sources of inaccuracies, you can analyze the false positive and false negative cases. Usability score, a system usability score from a questionnaire. This is a standardized questionnaire. And improvements, qualitative, so feedback from the analysis, from the usability analysis, so the usability analysis performed. So this is the connection, and this already makes clear what you're gonna do. Still, you didn't speak, notice, about the company, the context, etc. the context comes right afterwards. Okay. Of course, remember always that research questions may change until the end of the study. So here is the way that you should present the things. The things in practice can be that at the beginning you wrote down just vague research questions and you refine them, okay? And the context, of course, goes in parallel. But in a report, of course, you cannot parallelize much, okay? So I'm already oriented in telling you how to address the thing in a way that allows you to report them in a systematic way, but you cannot pretend, you cannot ask yourself to fill all the blanks in the context or in the research questions since the beginning, okay? There will be iterations, for sure, like we depicted and like we said many times. So the context, as we mentioned several times, is made of several aspects, or multiple aspects. The domain, in this case, would be a railway software company or safety critical company. The size, so a large company localized in a certain place or distributed. The type of activity that I'm interested in here, so the requirements reviews, because I want to automate this process of requirements analysis and review and correction. For example, the maturity of the company, so how many years in the field, or estimate the maturity according to the specific model. So you see that different theories also come to help in analyzing the context. Type of processes that are considered, agile, V-process, etc. The actors involved, and all the other peculiarities that can make a reader understand better what is your context, okay? To which extent your context is similar to theirs, so that they can understand that your conclusions can be applied also to their cases. The way to understand how to frame the context, how to explain it, is described in this tip. The question that you should ask yourself is, if this was an experiment, what are the variables that I cannot control, that are taken as given? This is the context that you should report. You cannot control the domain. You cannot control the size. The activity is already defined. Type of process is already defined. So these are all the aspects that, if this was an experiment, would be part of your controlled variable that you need to randomize in the experiment. But in the case study, you cannot. So context, we said at the beginning that is made of study subjects and objects. They are characterizing the context, but they have to characterize in more detail, because they are the actual subjects and objects involved in the study. For subjects, of course, you can choose, but you get what the company gives you. Well, you get the people that are available, and you cannot be much picky. So select and try to your best to select, but most of the cases is the company that decides. For example, 5 developers with 1, 2, 3 years experience, and 4 analysts with longer experience. In an experiment, you would say, hey, but these are not comparable. Okay, we will discuss this aspect in the interest to validity, but still you have 9 people from the company involved in your study. And it's a good number also, because, for example, for usability, most of the usability problems can be identified by 9 people. This was evaluated in the past, or by 9 or by 11. So by a limited number of subjects can identify like 80% of the usability problems in a tool. So you understand that even if they seem low numbers, is a lot, because there are people that have to be distracted from their daily work. Okay, of course you're helping them, of course you're developing a tool to help them their work, but currently they already have their process, and in most of the cases it's just the manager who wants them to change their way of working. And objects, here you probably have more choices, but you have to interact a lot with the company. You have to select the documents that are most representative or relevant for the company itself. So you have to discuss with the company and understand what is most appropriate. For example, you may select for this study low-level requirements, a document with 300 requirements and some requirements marked as defective, or higher level requirements with 100 requirements and 30 defective. Also in this case, it is highly unbalanced, this data set, because low level requirements have less defects in percentage. Okay, you need to discuss this aspect, because this is again some limited those limited data points that you are considering, and that highly impact on your actual study. Research design. So let's see how we design the different steps: data collection, analysis, and validity procedures. First element, as you remember, is the concept of unit of analysis. We discussed this already when we spoke about surveys. Okay, this unit of analysis in case studies, you have to consider as the case that you are studying. Okay, the case is, for example, people, companies, activities, artifacts. So is the subject the subject of your study, okay, the focus of your study. For example, in our example, we have the context, that is the company that we have chosen, and the case, so our unit of analysis, is the automatic defect detection task, because this is what you want to analyze, and this is what you want to improve somehow. The defect detection task, the review task, this is what you want to improve. So an activity, okay? This is characterized by a set of study subjects and a set of study objects. So the study subjects are the analysts who will evaluate the tool, and the study objects are the documents that will be used to evaluate the tool. This is, since we are looking at the unit of analysis as a whole, so like the company and the task is representative of the typical task of defect detection for the company, we speak about single unit and holistic case study. So just one unit of analysis that aim to give a complete view of that specific unit in the context of the company. There are several choices that you can have, and here you see it represented in this diagram. You have a single case study or multiple case studies. For example, context is always the company. Okay, what best characterize the specific context. You can have single case studies that are holistic, like the one that we discussed, and that are focused, for example, just on one team of analysts, or embedded. For example, in a large company, you can compare the usage of this requirements review tool by developers and by requirements analysts. So you have two embedded units, the group of requirements analysts and the group of the developers, and you want to compare. The same thing, you do it when you have multiple companies. Here, of course, the comparison and the dimensions grow a lot. And of course, you do a multiple case study when you have the availability of different companies that have similar needs. But of course, it's much more difficult to carry out, and you normally do it after you've done a single case study in more than one company. Okay. Of course, a multiple case study has more power for generalization, because if I test my theory, for example, in a railway company and an aircraft company, and I see that basically the tool that I developed works for both companies, then my theory is much stronger, because in two domains that are quite different, although still in transportation, the tool works. So probably it's very likely to work on the automotive industry, that is still a safety critical one. Okay, this is a typical design, and you should discuss them right after the context. So what is your general design? There can be variants. The design that I considered for my study was an holistic one, but I could set it up as an embedded one. How? For example, I want to focus on the case of defect detection, but not in general, but defect detection of high-level requirements. So in this case, I will consider only high-level document and study objects, and for the other case, defect detection on low-level requirements. So only low-level requirements and study objects. The study subjects can be the same. So analysts, the same group of analysts who will evaluate the tool. But the case is a variant with embedded cases, okay? Because why should I do this? Because probably my tool, because requirements are different in terms of level of abstraction. So my tool may work well for a certain type of requirements and might not work well on the other type of requirement. Okay, this is to give you an idea on how your goal, the goal that you have in mind, may modify your case study, make it more refined, and lead you towards an embedded case study or an holistic one. This is another possible variant. So defect detection by developers or defect detection by analysts. So these are another way of embedding, of having two different embedded units. So on one hand, you have the developers, and on the other hand, you have here there is a typo, but it's study subjects, is the analyst, and the study objects is the same requirements. So you keep the same requirements, but they are analyzed by developers and analysts. Of course, in here you may see already that there is additional choices that you may make, because for example, the ground truth that is made on the requirements could be delivered by the analysts themselves or by the developers. So there are variations also in the ground truth for starting the experiment, and you have to decide how it's better to frame it, what could be the threats of having basically two completely independently annotated requirements, because in this case you would have two sets of study objects, because there are requirements with annotations from different groups. So you understand that there are always little aspects in the design, also very, very tricky ones, that impact on your overall design and on the overall view of the study. And this is why I'm saying all this information here is shown in a sequential way, but in practice, very likely that you need to modify this aspect. Of course, especially for the design, for case studies, the best thing is to think beforehand about the unit of analysis and the type of study that you perform. Okay, because changing it later on may invalidate many of the data that you collected. So be extremely careful when you set up the design according to the paradigms that we listed. Then you have, of course, after the design, the data collection. We've seen this many times, data collection procedures. Here, of course, in case studies, you can collect quantitative and qualitative data with all the methods that we studied. Here, the key thing is, as I said already, the combination of multiple data sources. The issue is that you don't have much data, so you need to collect different viewpoints. This is the key things. You will not have a lot of quantitative data. You don't have a lot of interviews, so you need to get an in-depth and triangulated viewpoint on the same data. And it is important also to create a study database. These are the principles that you should follow in case studies. Create a study database, so a space where you collect and organize in a structured way all your data, and maintain a chain of evidence. So everything as starting from the goal question metric approach. You start from goal, you list research question, you identify your constructs, and measure your constructs so that your results are clearly linked to your research questions. For example, in our example case, as we said, we have quantitative and qualitative data. Okay, quantitative data are related to both usability and accuracy. Qualitative are related to possible improvement and sources of inaccuracy. We are still speaking about our tool for defect detection. Usability, as I said, we perform a usability evaluation questionnaire with a group of people, and we have a quantitative output. Accuracy, I measure precision and recall based on a comparison between the actual output of the tool and the expected output. For sources of inaccuracy, I do a manual comparison. So what are the false positive and false negative that can be identified? As you see, I already have 2 people doing this. Why? Because anytime there is a qualitative analysis to be performed, it is always more appropriate to have some form of triangulation. So independent people, in this case, doing the activity and comparing their results. Qualitative, for improvements, we decide to perform a focus group. After this usability test, the usability analysis, we perform a focus group and we ask, you see that there is a complete combination of different methodologies, partly not involving subjects and partly involving subjects in different ways, with a questionnaire, so something very similar to a survey, with a focus group, something close to interviews, or a manual comparison, so some document analysis. Okay, this is also to give you an idea of how interesting can be for someone who studied all those methods to apply them in practice in a little environment, but in a coherent way, and mixing all the stuff of the aspects together. And that's why I think case studies are the place where your creativity and your ability as empirical requirements engineer actually emerges. After data collection, you do data analysis. We have qualitative data and quantitative data. So for quantitative data, you perform some form of quantitative analysis. Up to now, we've seen quantitative analysis that are mostly hypothesis testing. Of course, here it is very rare that you have enough data points to do some hypothesis testing. So what you do normally is to provide descriptive statistics, or you use measures and approaches for other fields. For example, in our case, we will use approaches based on information retrieval, or as it is quite common now, if you introduce a tool that is based on natural language processing or any machine learning approach in a company for supporting automated software engineering, so software engineering that is supported by a tool like automated traceability, or automated code generation, of course, is not based on information retrieval or machine learning, but it is still a task for automated software engineering. You need to resort to measures that come from this other field to evaluate how good is your performance. For qualitative, you use qualitative methods, so apply coding, thematic analysis, and grounded theory, as we have learned. For example, in our case, for usability, we consider all our questionnaires, and we know from this link that established the system usability scale, we know that if the score is above 68, the scale is between 0 and 100. If it's above 68, will be considered above average, and anything below 68 need to be improved. So if up to from 68 to 100, we have a decent degree of usability. You already understand that you need some additional qualitative analysis to understand, to improve your tool. This number is not enough. What can you tell about this number? Just that it's decently usable. Okay. Qualitative, I have the list of improvements that came from my focus group. For example, they can have said that I think the GUI should distinguish between types of defect. Different defects should be associated also to degree of severity. I think that they should use color coding for different defects. So differentiation seems to be a common theme. So, but you apply on all the things that you collected, coding and thematic analysis, as you learned from our lecture on qualitative studies. For accuracy, data analysis concerns in evaluating precision and recall, and comparing with a precision and recall of a certain baseline. So understand the differentiation between data collection. Data collection means that you have collected your data, you have identified your data. Here, you want to interpret your data, analyze your data, okay? In interpreting your data, what does a certain value of precision and recall means? It doesn't mean anything if you don't compare it with a so-called baseline. The baseline can be another tool or a fictional tool like a random predictor, or a tool that simply says every requirement is defective, so that the analyst have to check all the requirements. So you need to show that to a certain extent your tool is better according to the measures. So this is the typical analysis that you do for any quantitative evaluation. For qualitative, you do the manual comparison, and again, you perform coding and thematic analysis together with by taking the information from the different subjects. Finally, so we spoke about data collection, so unit of analysis, data collection, data analysis, and then we want to say what are the validity procedures, what are the approaches that you have put into place to increase objectivity, okay? Because remember, you don't have a representative sample, not a randomized experiment, but still you want to reach objectivity, okay? You can do data source triangulation, so as collecting the same data at different occasions, observer triangulation, more than one observer in the study, methodological triangulation, so that different data collection methods, qualitative and quantitative, for example, like in our case, and theory triangulation, so using alternative theories or viewpoints to interpret your findings. In our case, for example, we perform data source triangulations because we decided to use multiple types of document, low level and high level, and we consider different degrees of defects, because we consider low defect documents and highly defective documents. And we had multiple analysts to perform defect analysis on the same document. This is for the definition of the ground truth, and we will discuss it in the next slide, this type of triangulation, because it's really relevant. Observer triangulation, for example, in this case, more than one interviewer asks users their feedback, quite uncommon for this type of studies because you have the focus group. And so it's normally handled by one person, but here you can have another person in the focus group, another researcher like you in the focus group. Methodological triangulation, so analyze quantitatively and qualitatively both accuracy and usability, what we have done actually. And finally, theory triangulation. For example, in this case, we are looking at the thing, we are looking at how good is this tool by the viewpoint of the information retrieval theory, so using the theory of precision and recall, and usability theory to evaluate the fitness of the tool for the company. So how good and how appropriate is the tool for the company. So you see that in our case, we can use all this type of triangulation to enforce, to increase objectivity in our study. Let's go to look at this last aspect, that is the presence of multiple analysts performing the theft analysis on the same document. I'm speaking about the construction of the ground truth, okay? Because so not the analysis that you do on the false positive and false negative cases to identify classes of cases with coding, but the construction of the ground truth that you'll be using. Why? Because we initially assumed that this ground truth was available. So the company gave us a document that was already reviewed for defects. But what if it is not? For example, there is no defect classification because they didn't perform any defect classification, or because they want to try on a new document, or because they have already delivered those products and they're not allowed to release the requirements, for example. For any reason, you might find yourself in this possible situation. So you need to build this ground truth. How to build it? You need triangulation. So you need to perform, in this case, a form of data source triangulation, but by having an independent manual classification of your defects in the requirements. So you take the original requirements not annotated for defects, and you analyze them. You have two subjects analyzing them. Then you compute the so-called agreement. So in how many cases they agree? Do the independent people agree? There are strategies, for example, Fleiss kappa and Cohen's kappa, to evaluate the agreement, and that gives you an indication of of the degree of agreement between the two people. If they disagree, in some cases they will surely disagree. In most of the cases, not in most of the cases, but in some cases that will disagree, they will discuss disagreement and come to an agreed ground truth. So a set of requirements for which they say, okay, this is surely not defective, and this is defective. So this is the process that you should put into place if you want to have a reliable ground truth. Who are these two people in the picture? They normally should be people from the company. So again, and this activity of tagging the requirements is time consuming. So there is again the usual engineering problem of resources, time, cost, and quality of the study. So here, in some cases, you may want to train other people, other students, but possibly not yourself, because of course you would be biased since you developed the tool, other people in doing this tagging activity. And you have to find a way to convince, for example, your colleagues to do this tagging. But it can be very difficult because these requirements can be written in the jargon of the company. So the best thing is always to involve someone in the company. If not possible, you need to train someone that can understand the requirements, because we discussed that people are using their jargon. If you look at the requirements, there is a project jargon, even not just a company jargon in these requirements, and they are not always understandable. So if I don't understand them, how can I identify defect in them? So these are side aspects that you should consider in practice when doing these example simple case studies, but is to let you make you understand that triangulation may be needed also for building the ground truth, and this is the approach that is normally used. Another thing is that if the agreement is very low, so Cohen's kappa is very low. The tables for Cohen's kappa you can find in Wikipedia. You need to give better instructions, because it means that your task is badly defined. Or why? Because these two people that you assume to have a similar background basically consider defective different requirements. So what's wrong here? You choose the wrong people, not representative of the company, or you didn't explain them the task well, or what they should consider defective or not defective. This can be visible if the agreement is low. And in this case, things get very complicated, because you have to redo the task, involve these people another time. So the best thing is start from a sort of set of requirements in which you already start giving them instruction and let them agree on a strategy for tagging, on a strategy or requirements defect identification. Otherwise, it is very likely that the agreement will be very low. Okay, so they start on a pilot number of requirements. They agree on the strategy. You define with them all together the strategy, so that the differences are just for corner cases, the difference that they will have to discuss. Otherwise, the study may be considered as quite flawed, okay, quite erroneous. So this is just an explanation of what I just told you. A ground truth, why this is not just representative of this specific case, but is representative of any case in which classification is required. So defective versus not defective, relevant link or not relevant link, erroneous statement, not erroneous statement, bug, not bug. Anytime a classification is required, this type of analysis and construction of the ground truth is needed. So you need independent subjects to independently classify the data. Of course, you may have more complex cases, because classification is one of the simplest theoretically tasks. So you may have, in the case of code generation, you may need different evaluation measures, or in the case of, for example, comment generation, that is another activity that may be needed. The evaluation may require some measures from the natural language processing field. So consider that you are bringing a tool and you need to evaluate it. The strategies for evaluation are found in fields like machine learning or natural language processing, information retrieval, this type of fields that you normally apply for improving the software engineering process. So let's have a break.